we're factoring polynomials using the factor theorem, and we want to check or show that the binomial x minus 6 is a factor of the polynomial x cubed minus 5x squared minus 6x. So this polynomial doesn't have the constant term, so we have to add it on as a placeholder when we're doing synthetic substitution. So we use the zero product property to check the binomial for the zero. So x minus 6 equals 0. So add 6 to both sides, x equals 6. So using synthetic substitution of 6, we're going to find out what the remaining polynomial is. So add down, multiplying the diagonal. 1 plus 0 is 1. 6 times 1 is 6. Negative 5 plus 6 is 1. 1 times 6 is 6. Negative 6 plus 6 is 0. 6 times 0 is 0. 0 plus 0 is 0. And we know that our remainder is 0, so x minus 6 is a factor. Then we have our constant term. Then we have our linear term. Then we have our quadratic term. So now we can rewrite our polynomial in somewhat factored form because we know that x minus 6 is a factor. And then we can bring down our remaining polynomial. So we know that on the quadratic term we have x squared, and then we have a linear term of x with no constant. So our lead binomial is already factored, and then we have to factor, we know that we have an x squared and an x, we have an x in both of those, so we can factor that out. And so we have x minus 6, and then we factor 1x out, and then we're left with x plus 1. And so we solve each one of these, and we get, if we substitute in a positive 6, we get 0. If we substitute in 0, we get 0. And if we substitute in negative 1, we get 0. So the solution for this, the factors for this are x equals negative 1, 0, and 6. And because we had a cubic function with the highest degree of 3, we know that we should be looking for 3 zeros.